Hi everyone, welcome back to our tutorial sessions. We took a few weeks of break and we are so excited to come back and continue our tutorials together. I hope you rewatched some of our videos that we did together, and if you remember, our last video was on memories, and today, to continue the topic, we will study about processes in memory. So let's start. What's on our agenda? In our agenda, we have introduction to processes in memory and sections of process in memory. Under each of these two sections, we have definition of the process and its importance in operating system, basic concept and structure of a process in memory. Under the second section, we have description of the sections and their roles. And then we have finally summary. So the picture here describes how a computer uses memory. We have, of course, input devices like mouse, keyboard, scanner, microphone, and video recorder. We have storage devices like ROM, removable storage, hard drive, network storage, and we have RAM, read-only memory, physical virtual RAM. We have, of course, cache, which is part of temporary storage, and then we have CPU. And then, as you can see, the whole diagram is basically data, it's part of data access hierarchy. So what is the process in memory? Process is an instance of a program in execution. It encompasses the program code, current activity represented by the value of the program, the contents of the process registers, process stack containing temporary data. Additionally, it includes the process heap, which is memory dynamically allocated during process runtime. So, how is it important in operating system? Processes are fundamental to the operation of an operating system. They provide a means for the system to execute multiple tasks seemingly simultaneously. The operating system is responsible for managing these processes, including their creation, scheduling, and termination. Effective process management enhances system efficiency, responsiveness, and security by ensuring that each process gets adequate CPU time, that processes are isolated from one another to prevent interference, and that resources are allocated and deallocated properly. The basic concepts and structure of a process in memory. The memory processes consist of several sections, and they serve for specific purposes. For example, text section. It contains executable code of the program. It's usually read-only to prevent modifications during execution. Data section. The segment is divided into initialized and uninitialized data sections. The first one contains global and static variables that have been initialized by the programmer. The second one contains data section that are initialized to 0 by default. We have stack section. The section is used for local variables, function parameters, return addresses, and control data. It grows towards lower memory addresses and is managed automatically by the compiler. When a function is called, new stack frame is created and is destroyed when function exits. Program counter. This is not a section of memory per se, but is a crucial component of process state. It holds the address of the next instruction to be executed, ensuring the correct sequence of operations. Register status. This includes the values stored in the CPU registers such as accumulator, index registers, status flags, which are essential for the process's execution state. sections of a process in memory. That's part of the second section, if you remember. And here we go through different sections and their description as well as their role. The first one is command line arguments. Command line arguments are inputs provided to a program when it's executed from the command line or terminal. They allow users to pass parameters or configuration options to the program. What's their role? Their role is typically stored in the stack section of process memory. They enable the program to operate in different modes or with different data without modifying the source code. The next one is text section. This, also known as the code section, contains executable instructions of a program. This section is typically marked as read-only to prevent accidental modification of the program code during execution. It ensures that the instructions that the CPU executes remain consistent and unaltered. So the next one, data section. The data section contains global and static variables that are initialized by the programmer. The role is divided into two parts: initialized data segments, which stores variables that are initialized with a specific value in the program, and then uninitialized data segment, which stores variables that are declared but not initialized by the program. The system initializes these variables to 0. Stack section. The stack section is used for managing local variables, function parameters, return addresses, and control flow data. What's the role? The role, it grows and shrinks dynamically as functions that are called and returned. The stack operates on the last in, first out basis, which is LIFO, which helps in managing nested function calls and local variable scopes efficiently. Next one is heap section. The heap section is used for dynamic memory allocation. It allows programs to allocate memory at runtime using functions like malloc, calloc, realloc, and free in C, C++. The heap grows towards higher memory addresses and provides flexibility for programs that require variable amounts of money during execution. Program counter. The program counter holds the address of the next instruction to be executed by the CPU. The program counter ensures the correct sequence of execution of the instructions. It's incremented after fetching an instruction and can be modified by control flow instructions like jumps, calls, and returns. And finally, we have register status. On the register status, the values of the CPU registers, which include accumulator, base register, index register, stack pointer, and others. Registers are small, fast storage locations within the CPU that hold data instructions that are being currently processed. They play a crucial role in execution of instructions, temporary data storage, and arithmetic and logical operations. Here we have references, and let's just go through a quick summary. So today we basically learned about processes and memory. We had two sections, introduction and then the sections of process memory. First we defined the process and its importance in operating system. Then we went deeper into basic concepts and structure of a process in memory. Then we learned about the sections of a process memory, like command line arguments, text section, data section, stack, heap, program counter, and finally the register status. We hope by watching this video you will learn basics of the processes in memory, and hopefully we will meet again next week to continue our tutorial. Keep watching, like our video, subscribe to our channel, and don't forget to keep learning. Till the next video. Bye bye.